Hello, welcome back. I'm sure you did a bit of a on the spot march and running and had a bit of a refresher and got your energy back. Now let's get into the interesting bit to learn step by step from scratch about learning to write your own code, and you will see the output in the board here, which is the target board that's I connected to my computer. So let's get in and get started to learn to program. For ease, I'm going to minimize this and we're going to go into the STM32Cube IDE. So I'll start. I already opened it and it's there. So once you are here, go to File, New, and start STM32 project because we are programming for the target. If you program not for the target, if you program for the computer, then it's called a host. It's a C++ program, but if you target a board, meaning a hardware, then that's where it's called a target. Okay, in the target selection, go to board selector. If you know the part, you can type in here, which I know because I'm staring at it. It says Nucleo F411, which makes it easier. If not, you need to scroll all the way down and try to find, so which is time consuming. So even here, if you click on the drop down, there's plenty out there, and that's another way that you can go and look for F11RE. If not, then you can just type in there. So choose that, highlight this here, come here, click here, otherwise the next one highlight or enable, click on next. Now it will prompt you to ask for a project name. You need to give a project name. We are on day 7, so I'll put day 7, and the first project is we're going to learn about blinking and LED. So I'll say blink and LED in short. Project name is really important because if someone else in the team, when you're working, and if they want to use, for example, your code into other parts of the world sorry, other parts of the code in a multi-interfacing integrated code, then they all talk with project name. So your senior engineer would ask you where is that sitting. So you can just say Day7, for example, blinking LED. So the senior engineer would know exactly where to go. So that's why project name should almost resemble as close as what you are trying to do, what you are trying to achieve by writing the code. Since I'm going to start to teach you from scratch, I'm starting here in the target project type as empty. For complex projects, you can start as STM32Cube. And the other two, please leave it as targeted language as C because you're going to learn embedded C program. And the targeted binary type is executable. So click empty and finish. This will fetch all the necessary files. As you can see, it's downloading everything, and once it's ready, it will take you to the project page, which is here. As you can see, it created the project tree, day 7 blink LED. We need to go to source files, we need to go to main.c. So double click, and the one with slash and star and ends with star and slash, this part, it's called as a reference part. So you're going to explain what is this program is about and who has written, and whether this is in a header or in a footer part of the, say, 20,000 lines program, or is it in the main program body. So you need to just tell that so anyone who comes there in your team can understand. So this is how in real industry, this is how they have in every project. But being you're learning new here, you don't have to worry much about it, but it's out there for your learning. So I'll just leave it there. You just for your reference. You can just go back and you can read it. Okay, so I'm going to teach you from scratch. So I'm going to delete everything that's inside first. Not that. Sorry, my mouse is playing up. One sec. I'll delete that. I will delete this also. As you know, every function has to have a return value. We are not returning anything here. Sorry. So it's just set as return. And I'm testing to build the project to compile. So this will create the .elf file, the executable linker file, which is very important because that's the file you're going to program and send it to the targeted board for your program to work. So .elf is very important. It has to be error free and warnings free mostly. Warnings are not a big concern, but you need to make it error free, otherwise your code won't work. So to generate that .elf file, right click on your project name, go to build project, and this starts building with ARM, NUN, EIB, GCC, all that. It looks for possible errors and comes out as 0 errors, 0 warnings, which is a very good sign. If you remember, we enabled or set a folder in desktop right at the start as EST ARM Cortex M4 demo, and created a folder called target because we are targeting the board. Target. So you have given this name Day7 blink LED. So if you go there, because you compile, once you start to compile, then you get your file, .elf file will be there. So that's why I did this. For example, if you go back to other files, you can't see. For example, I'm going to show you push button. So if you go push button, you can't see anything, but that's a temporary file that's there, but you won't see the other files. That's what I mean. Okay. So we did the first part by generating that .elf file, which is a must. That is the application file. You are targeting that to debug or to run the program on your board. The next step is the second step, debug settings. So right click on your project name, Day7 blink underscore LED. Come down to debug as, then go to debug configuration. Come to debug as, go to debug configuration. Once you are in, it automatically chooses the project name if it is on list. If it doesn't, then just click on this. Come on. It's making a liar out of me. Sorry, one sec. Double click. Okay, there it is. It took a while to show. By default, it will come as the current project that what you are working. Day7 blink LED, Day7 blink LED. If you don't see it here, click on STM32 and do a double click. That will basically refresh the debug configuration and it will get selected. And then inside the main configuration, make sure you are working on the same project by checking on the name Day7 underscore blink underscore LED debug. And the project, if you are not sure, if you click on browse, then there is a list of projects. You are working on Day7 blink LED. Be sure you are on the correct project. And this is the one is very, very, very important. So this is why I compile. I build the project to get the .elf file, because you need to target the application through .elf. So if you're not sure, click on browse or click on even search project. Sorry, you can also click on search project, and if you click on ELF, and you can just hit OK. So it gives you that ELF file. Or you can go by browse and you need to locate where the file is on desktop, ESD ARM Cortex, on target, Day7 blink LED, inside debug, there is a file. Okay, I'll cancel it here because I already linked it. So once you make sure all the three is there, then the next step is you have to go to debugger, because you need to debug this as well. In the debugger, you need to go to interface and you need to choose st-link, because you are targeting the target board, and it has to, when you click on debug, this is the debug section, the top bit, so this has to be connected to your computer, otherwise it will throw error. So that's why you need to enable that. And to see your output in the window itself, like SFRs, etc., that's a serial wire viewer, so you need to make sure to enable this. So these two are the main in debugger, ST-link and SWV enable. Once you've done these two, you don't have to do anything with startup or source or common. You're finished, you're done in configuration settings for debug. You just click on apply and then click on debug. What it does is, you are on C++ perspective. This will change to debug configuration, where you will get to see the different variables, expressions, special function registers, etc. So it will ask you to switch. You click on switch, and this is the file you will get, and it will come and stop here. So I'll show you how to view SFR files. SFR is nothing but sorry, SFR is nothing but, I beg your pardon, special function registers. How to view it? In your IDE window, it's up here on the top. Go to window, go to show view, and come down on the list. There is SFRs. Click that, SFRs, and this SFR window will open. So the first thing we need to know is 3 steps that you need to do for the LED to operate. What are they? HB1ENR, it's under RCC register, and you need to set the mode register as output. You need to set the output data register as output. So these 3 you have to do. Before doing that, I'll show you a bit of a magic. So you need to go to RCC, and you need to look for AHB1ENR, that one, and you're going to enable GPIO port A. So double click that. Sometimes double clicking enables. If it doesn't, then just type 0x1 means enable. Then that's enabled. Then what is the next step? Then you need to go to GPIO A modder. GPIO A. Go to modder. Modder is the directory register. You're saying which directory is which, and you need to change this 10 by 2. I'll explain to you in the code in a minute when I write the code. So set this modder to 1. And what is the third step? You need to set up the output data register. Output data register, same, the modder 5, that's where you need to enable. So you come here, modder 5, ODR 5, and I'm going to enable this bit. So please watch what happens to the LED as soon as I enable this LED and hit enter. Please watch carefully. See, LED is coming on. And that's how you view the SFR registers. So this is coming via the registers. These 3 steps. So this is a hardware check. This is how you go to each and every individual step, and you're going to see how it operates. So let's set this back to default, so when I press 0, you watch the LED, it will disappear or turn off. Okay, I'm going to teach you how to, by writing coding, to see how to get that LED on and off. Okay, so let's begin. First I will start with bit field uint 32_t, and it's a pointer variable. So the first is RCC AHB1 ENR, because that's the first step. AHB1 ENR, we need to enable, telling the microcontroller you are using GPIO-A port, so you need to enable the peripheral clock first. So you have to go, as you know, go window, show view, go to SFR, you'll get this. So in this, go to RCC, go to RCC, and you have to go to AHB1 ENR, and you need to copy this address 0x4023830, copy this, and that's the value you need to set. Copy and paste. Okay, because what this is uint32t, it's a bit field. It has to give that as a type def, because it has to be compatible with other IDs as well, so that's why you use uint32t, and that's a pointer declaration, asterisk point, asterisk p denotes pointer, so pointer you're directing to that register. Oops, sorry. And you need to typecast this, meaning you need to tell the bits, sorry, uint32_t, star, and that's the value you need to set for that. Okay, so I'll reset that, and then I'll go to modder. I'll reset everything and I'll show you bit by bit through the programming. Okay, modder file changed. What happened to ODR file? Okay, that's also changed. Okay, so the first step we finished. Now what is the next step? So we set to the or we told the microcontroller we're going to use GPIO port A. The next step is you need to enable this port. And how are you going to enable? You just copy that. You need to set this port. To set, you're going to R, bitwise R with it. So that's the symbol. You're going to set the GPIO bit 0. So this is how you write to set. Okay, so the first step is completed. You set the microcontroller, you're going to use, you enable the peripheral, and then you set up the GPIO port A, which is bit 0, you set as 1. Okay, so let's build and see where we are up to. In the project tree, right click, build project. Two errors. uint32 U in 32 expression. U in 32 expression. I'll give that as a command. No need of this one. Say build. Okay, now it's 0 error. So now let's check on the SFRs. We need to go to RCC. See, it's 0 cross 0 0. So I'm going to do a step in to watch the value here. First step into comes out. I will set a breakpoint and I will, this is one to terminate and relaunch. So I'm going to terminate and relaunch to see the SFR operation. Okay. Debug configuration, come to debug. Yeah, chosen blink LED, debugger, ST-Link and enable. Yes, go to debug mode. It's loading, 0 errors, 0 warnings. It's still loading to 79%. It will ask to switch, waiting for the debugger connection. There it is, switch. So now I have set the breakpoint. Let's see the value here. GPIO enable, this one has to change to 0 1. I will do step run. See, now the value has changed, 0 1. So this is the code that you asked the microcontroller to do. Before I did it manually, but now you have written these 2 lines and you executed by going into step into, and by default automatically you told the microcontroller you enable the peripheral and also you set up the GPIO enable, port A enabled. So what is the next step? Next step is to set the mode register. How are you going to do that? Okay, so I will write the mode register. I will copy this, Control C, enter, Control V. What is the mode register we are after? So we need to go to GPIO A. GPIO A, that's a moder. So we need this address. You need to copy this address, which is this address. Copy this, Control C. You come here and replace with this, and also that's your moder, GPIO A output moder. Okay, and you need to set this bit and you are R-ing this bit. I'll show you in a tick. You have to shift 10 times to write 0 1 in this output moder. You save this. I'll show you in the data sheet. Okay, the first step, we set GPIO A as 1. So we enable the clock register. The next one is not the peripheral, output mode register. That's peripheral clock. Clock enable in low power. Output port mode register we are after. Keep scrolling, keep scrolling, keep scrolling. It's a control register, we don't want that. It's a clock generation register, we don't want that. We need to go to port mode register. Port mode. It will be on starting GPIO, so it's on section 8. You will see GPIO started here, so that's a theory that we learned earlier. I'm going to show you where the port is. Port mode register, why I did the 10-step bit shift operation to the left. Okay, so this is the port mode register and we are using 0, 1. So we got to write on mode R1 is to 0, that's 0, 1 as the output. So you need to write 0, 1 here. So that's why there is a 10-step count. So 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. And when you come here, you have to write 0, 1. So that's what you're saying with the bitter on the configuration 0 to 15. So that's what this means, the 10 shift. So now you're ready with the 10. That's a bit shift operation. So now let's check what the SFR is going to do. So I will do another run and I'll keep the modder 5 on. So watch this step. I will do another breakpoint and step into, keep watching, step into the next step. I'll remove this breakpoint so you won't get confused. Now I'll hit and relaunch so I can show you the modder change in the code. Zero error, 0 warnings, that's what we want. That's good. So actually we are writing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This bit you're writing 1, that's a 0. Switch. So now let me run and see modder 5 will change to 0, 1. Step into GPIO mode now. Now watch. See, the modder changed there. So it accepted our code. Now the microcontroller knows that that's set as an output mode register. So this is what I did earlier. I enabled this manually, but now you have written this code and you're also verifying that through SFR, which is equally important. So if you are in doubt, go to SFR and then see for yourself whether your code that you meant to write, is that happening. Check bit by bit and register by register. So we are good, we are progressing well. So what is the next step? Now we need to see the LED to toggle on off. Okay, so how are you going to do that? Okay, it's not difficult, so I'm going to put a simple while loop. First of all, I'll remove this breakpoint so you won't get in the way. Then I'm going to write a simple while loop. And what is the third step? Before writing that, you need to save the data and read the data, write from the data. So what do we need? The third step, ODR. So we need to copy this address, ODR value. Third step, come here, copy PGAO mode A ODR, output data register, and you need to copy this offset value. Address offset is base value plus offset you have to give. That's the offset. So come here. Basically you are linking what you want to use that register as, that pin as. So that's what you need to specify to that address. So that's why you're giving that. Okay. So now you need to use this ODR. That's why you're given that, and you need to configure this and ask it to blink because that's where your data is sitting. Control C, come to while loop. And how are you going to set? Again, to set on, you have to do bitwise R. Bitwise R, motor 5. Setting up high, and to clear you need to write you need to and negate it to clear. Control C, Control V. You need to do a bitwise and negate this value to toggle. Negate. Yeah. So save and run this project, build. Okay, so if I set the breakpoint here and here, and I'm going to go step into, so watch with ODR 5, see the toggle, ODR 5 there. Okay, and step in, sorry, I set 2 breakpoints. This. Stop and relaunch. Because there is no delay, you won't be able to see the blink because it's hard to capture the on state and the off state, so therefore you need to have a bit of a delay so you can see the transition between on and off. So I just compile it and I'm going to run as a flush and see what happens. So it comes and stays on, and because there is no delay, so your program is working actually. The LED is on, this LED is on, but there is no delay given, so therefore the transition state between zeros and ones you can't really capture, so that's why it's there. So I'll remove the breakpoint. I'll remove this. I'll remove this and I will introduce a small delay. So delay off, and also tab delay off. That's finished, and I need to write a function for delay. So void delay off, start the braces and end the braces, then open a for loop for u int 32 underscore t I equals 0, I as in random delay, and I increment. Okay, so delay is finished. Save the project and build it again to check for errors to see if you made any mistake. Okay, so now it's all ready. You did the 3 steps. You set the enable, you set the output data mode register, the output data is going to negate. It's all in there in place. So now let's closely watch what happens when you compile and resume. You have to come here and click on resume. And the program will start to feed and come to while loop. Just give me a sec. Okay, I think I have to remove all the breakpoints. Is there any breakpoints? Remove all breakpoints. Yeah, I removed it. Now resume. No function, so I'll terminate and relaunch. Okay, I'm asking it to switch. Almost there. So we switched. Now I'm going to run in flush, so it's outputted to run. So voila, there you are. You have written the program, and now you making the LD to go blink, 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 on and off, on and off, on and off. So it depends on the delay what you given. It's blinking, so the more changes in the delay that you change, the frequency of this on and off transition will happen. So well done. You have learned to do the first project successfully, and congratulations, you learned something which this will be useful for further projects. So I'll give you your deserved break, so go for your break. When you come back, I'm going to teach you about using a push button to how to use it and control this LED again. So go and have that break shortly. I'll see you back. See you then.